Astronomers have identified 5 multiple stellar systems with permanent habitable zones. Through the use of data connected to Kepler 34, Kepler 35, Kepler 38, Kepler 64, and Kepler 413, which are multiple stellar systems located between 2,764 and 5,933 light years away. These systems are found in the constellations of Lyra and Cygnus. Data presented supports that these systems may have permanent habitable zones. A habitable zone is a region around a star in which liquid water could exist on the surface of any yet undiscovered Earth-like planet. Of all of these systems, it seems data supports that Kepler 64 is known to have at least 4 stars orbiting one another at its center, while the other systems have 2 stars. All of these systems are known to have at least one giant planet, the size of Neptune or greater. Based on astronomers' observations, life is far most likely to evolve on planets which are located within their system's habitable zone, in a similar way to that of our Earth. Their intentions are to investigate whether a habitable zone exists within these 9 known systems, with 2 or more stars orbited by giant planets. They have been aware for a while that binary star systems without giant planets have the potential to harbor habitable worlds. They also have observed that in a large fraction of those systems, Earth-like planets can remain habitable even in the presence of giant planets. Astronomers have so far investigated the effects of stellar binarity and circumbinary giant planets on the habitable zones of 9 systems: Kepler 16, Kepler 34, Kepler 35, Kepler 38, Kepler 64, Kepler 413, Kepler 453, Kepler 1647, and Kepler 1661. They have also managed to confirm that Kepler 16 and Kepler 1647 are not suitable for hosting a terrestrial planet within their classical habitable zone. The studies have also suggested that Kepler 34, Kepler 35, Kepler 38, Kepler 64, and Kepler 413 seem more promising than Kepler 38. Kepler 38 being the best and most suitable candidate. The habitable zones of these systems are between 0.4 to 1.5 astronomical units wide, beginning at distances between 0.6 to 2 astronomical units from the center of the system, of the mass of the binary stars. Kepler 453 and Kepler 1661 stand between the previous 2 categories of systems. The best candidate for hosting a world that is potentially habitable is the binary system Kepler 38, which is approximately 3,970 light years from our Earth and is known to contain a Neptune-sized planet. The research work confirms that even binary star systems with giant planets are hot targets in the search for Earth 2.0. Kepler 38 is a binary star system within the constellation Lyra. These stars, called Kepler 38a and Kepler 38b, have masses of 95% and 25% solar masses. The brightest star is a spectral class G star, while the secondary star has a spectral class M. They are separated by approximately 0.147 astronomical units, and they complete an eccentric orbit around a common center of mass every 18.8 days. So far, a circumbinary Neptune-sized planet was found transiting the brighter star. Observations which followed would not provide any sufficient information to constrain the mass of the planet. The planet was confirmed via transit duration variation method. It is, however, quite likely that additional planets exist in the habitable zone of this system, which would include rocky terrestrial planets, based on simulations of the formation of the Kepler 38 system. Also, the orbits of any such planets are possibly quite stable. Like, comment, share, and subscribe. Let me know what you think about these fascinating discoveries being made by astronomers in relation to these 5 Kepler systems that are believed to host habitable zones. Of course, with the most promising being Kepler 38, which is a planetary system that hosts at least one planet that is the size of Neptune. The system is a multiple star system. It hosts at least 2 stellar components. It has a stellar binary semi-major axis with Kepler 38a and Kepler 38b, along with the circumbinary planet Kepler 38ab, which is a p-type semi-major axis at 0.464 astronomical units. Thanks for watching and goodbye.